Welcome to this Mastering Array with Numpy tutorial. In this quick tutorial, we will explore the basics of creating, manipulating, and performing calculations on arrays using Numpy, which is a powerful numerical computing library in Python. Numpy is known for its speed and efficiency, thus making it a go-to choice for data scientists and engineers. We first import Numpy as NP. Then we're going to create one-dimensional or two-dimensional arrays. So we will see both one-dimensional and two-dimensional arrays. To create array, Numpy array, we are going to use array functions and pass list of integer numbers or floating point numbers into that array function. Let's go. This is a one-dimensional array with numpy or np.array function, and we pass list of numbers into this array function. This is the process of creating one-dimensional array. We can print out to see this as a result. So it's just prints list of numbers as a result when printing out that array object. The next is I'll show you how to create two-dimensional array. In two-dimensional array, the array has two dimensions, row and column. All right. We use the same process to create two-dimensional arrays as we created one-dimensional array. But the only difference here is we just specify the columns and rows of the elements. So this array has 2 rows and 4 columns. Okay, so this is called two-dimensional array. We can see that the two-dimensional array as a result. So this is what a two-dimensional array. So we use sublists separated by comma to create a two-dimensional array. So this is called matrix. Okay, the next is array operations. We will see some of the array operations. For example, element-wise addition. So we can add any number into the array elements. Let's see. So this element-wise addition, I have added 10 in each element of the array. Initially, it was 1, 2, 3, 4, 5, but after added 10 in each element of the one-dimensional array, the elements are now changed to this one, 11, 12, 13, 14, 15. It just added the number 10 in each element of the array. So this is called element-wise addition. We can also perform element-wise multiplication. Let's see how to multiply each element of the two-dimensional arrays. All right, I just multiplied each element of the two-dimensional array by 2. So this is called element-wise multiplication, and now it is changed to just 2, 4, 6, 8, 10, 12, 14, 16, but I have created 1, 2, 3, 4, 5, 6, 7, 8 initially, but after multiplied each element by 2 and the element of the array is changed, okay? So this is called element-wise multiplication. We can also perform any other operations. So this is some of the examples how you can apply element-wise addition, multiplication. You can also perform division, square root, or any other array operations. Okay, next, array manipulations. And this array manipulation, we can manipulate our array data. We can transpose the rows by columns. We can reshape the one-dimensional into two-dimensional, or also reshape the two-dimensional rows and columns. Okay, this is called array manipulations. So let's transpose a two-dimensional array. Here, I created 2 by 4 array, but now I transposed into 4 by 2, and the rows are transposed into columns. So we can use transpose function from Numpy. And we can also reshape, for example, I have one-dimensional array, but I can reshape that one-dimensional array into two-dimensional arrays by specifying rows and columns. For example, I have 5 elements in the one-dimensional array. So to reshape this, okay, now it is converted or reshaped into 5 rows by 1 column. But it was one-dimensional array. Now it is two-dimensional array. So this is the first one is row, not the number of rows, and this one is the number of columns. So when you multiply row by column, you get the total number of elements. So that is what reshaping arrays. For example, if you specify 6 by 1 in the one-dimensional array, you get error because cannot reshape array of size 5 into 6 by 1 because it gives 6 total number of elements. We had 5 total number of elements, so we reshape into 5 by 1 or 1 by 5, 1 row and 5 column. Okay, the next is going to aggregate our arrays data. For example, we can sum all elements in the array. So the sum of the one-dimensional array is 15. So we can use sum function from Numpy to sum all elements in the array. So that is called array aggregation. And we can also find the mean of all elements in the two-dimensional array or one-dimensional array. So mean of three. So that's 4.5, the mean of two-dimensional array. So we can use mean function from Numpy. The next step is array indexing and slicing, which means accessing array elements by indexing. Index starts from 0 up to n minus 1. N means the total number of elements in the array. The first element in the array is found at index 1. So we can accessing that element by referring the index or the position of the array. For example, the first array element in the first dimensional array that is 1. 1 is found at index 0, which means the first element in the array. What about if we want to access the two-dimensional array? So we have two-dimensional array in this case. So we have rows and columns. So for example, I want to access the first element in the array, in the two-dimensional array. I can use like this, but it just printed the first row. That is the first position, the first row in the two-dimensional array. It prints all elements in the first row. From the first row, I want to access the first element. I just pass another index. That is the first row, the first column. It means, for example, sort the first row, but adds column 4 is 4. So this is how to access two-dimensional arrays. And the other is we can slicing let's have elements from array elements. For example, array 1b, I want access from index 1 up to 4. That is 2, 3, 4. The index 1 means the second element in the array. Index 4 is not including the last index, actually, just excluding the last, but including the first or the start index. Okay. All right. So we can do many things. We can slice any sub elements from array elements using slicing, accessing with index. And the last is a speed comparison. NumPy operations are basically optimized and run faster than traditional Python lists for large data sets. So here I will show you how to demonstrate with a quick examples to compare the speed of traditional list and NumPy array. I first create a list and NumPy array with the same data. Okay, here I created list of numbers from 1 up to 10 raised to 6, and the same is for NumPy array. I created 1 up to 10 raised to 6 NumPy array and Python list, and I'm going to compare the processing time of both list and NumPy array. So let's dive into which one is fastest and optimized to perform large data sets. Look, I just use the same data and just measure the processing time of find the sum of the Python list and the time it takes to process the sum of the Python list is this seconds. Look, 0.0119. But to sum NumPy array with the same data takes smaller time when you compare to the traditional Python list. So in conclusion, this uh, NumPy array is more powerful than traditional list, especially if you are working on large data sets. This is what's the best thing that NumPy array is efficient and optimized for large data sets. So this quick tour highlights NumPy's efficiency in array operations. Mastering NumPy opens doors to efficient numerical computations, making it an essential tool for scientific computing and data analysis. I hope you uh, get some insights about NumPy array, and you can practice more and learn more about NumPy array, and you can be proficient in NumPy array in working with scientific computing analysis. Thanks for watching.